Welcome to our mathematics lesson. In today's lesson, we are going to discuss about very crucial rules about the divisibility. Before we discuss more about fractions, we need to know about these rules, which are known as divisibility rules. Now, what we do in these rules, in divisibility rules, we do not divide a number by hand. We usually do not divide a number by hand. In other words, in other sense, you can say this is magic that we just seeing a number can easily tell that this number is divisible by 2 or divisible by 3 or 4, 5, 10, 6, 8, 11, 15. So such rules are known as divisibility rules. Once again, I am going to repeat my words that divisibility rule makes easier understanding about the numbers, that we do not divide a number, and without dividing a number we can easily tell that this number is dividable by 2, 3, or number 4, or even by 5, or even by 10, 11, 15, or even by 25. There are such rules available which tell us how to divide a number without dividing the numbers. We can, in other sense, we can say this is magic that just seeing a number, we can tell that is this number divisible by a specific number or not. Now our first rule is divisibility by 2. If a number is even, then it is divisible by 2. If a number is even, then it is divisible by 2. Now what are even numbers? Even numbers are those which have digits like 0, 2, 4, 8 at their ones place. Such numbers are known as even numbers. Even numbers are those numbers, numbers, numbers which have digits. Digits mean each single value. Each single value in a given number is known as digit. Numbers which have digits, and these digits are very specific. We can't change these digits. Numbers which have digits, which digits? 0, 2, 4, 6, 8 at the place of ones. Now what are ones? We know where you must know about ones, tens, hundreds, ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 million, 100 million, billion, 10 billion, 100 billion. This concept is known as uh, is used to read a number in words. So numbers which have digits 0, 2, 4, 6, 8. So these are digits 1, 2, 3, 4, 5. These 5 digits. If these 5 digits, if any digit from these 5 digits appear at the place of ones, such numbers are known as even numbers. Such numbers are called even numbers. If numbers, if we are with different numbers and their ones place is having 0 or 2, so such numbers are divisible by 2, with by 2 divisible completely by 2 completely. That completely means when we divide such numbers we have 0 as a remainder. We have 0 at the end of a division as a remainder when we divide such numbers. So if we have numbers which have 0, 2, 4, 6, or 8 at their ones place, such numbers can be divided easily and completely by 2. Now we have some numbers in example like 158. This is our example number 1. Now in 158 you can easily see that at ones, now this is ones place, 8 is at ones place, 5 is at tens place, and 1 is at hundreds place. So this is 8, this 8 is at ones place. Now this 8, see, at our given scenario we have 0, 2, 4, 6, 8. Here we are having a digit 8 at in this number which is 158, and this 8 is available at is placed at the place of ones. So this number is an even number. This number is an even number. So seeing this number we can easily say that this number is divisible by 2. Understood? Okay. If not, we are going to have another example. We have a number 1010. Now we we this 0 is at ones place. This one is at tens place. This 0 is at hundreds place, and this one is at thousands place. Now we are discussing about which place? We are discussing about ones place. If we are having 0, 2, 4, 6, 8 at ones place, so such number is known as an even number. So this number is also an even number. Understood? Okay, we continue with another example. So this number is also divisible by 2. We are going to have another example. We have a single digit number which is 4. Now is this 4 divisible by 2? Yes, because this 4 is also an even number which is here in our given list. We have 5 digits to prove that a number is an even number if these digits occur at the place of ones of any given number: 0, 2, 4, 6, 8. These are 5 digits: 1, 2, 3, 4, and 5. So this 4 is also is an even number. Now we have fourth example. We are going to discuss fourth example. Suppose we have a number which is mm, like 7, 5, 3, 2, and 6. Now this is a bigger number. If we ask someone else that is this number divisible by 2 or not, unfamiliar person will take a calculator and divide this number by 2 if that person doesn't know the divisibility rule. But for the students who study mathematics, they can easily tell that this number is also a first, this number is also an even number because we are having 6 at their ones place. This is very crucial. This is a condition to be a number for an even number. the number which will have which have which has a digit, even digit at the place of their even digits. These are even digits: 0, 2, 4, 6, 8. These all are even digits, and these even digits, whenever we found at the place of ones, we can easily say that such number is an even number and easily divisible by 2. So we are having here 6. We are having here 6 at the place of 1. This is also divisible by 6. Now we put our finger tip at 6 and look at the remaining number. Now at the place of ones we are having 2, and this 2 is also an even number, so we can easily say this number is also divisible by 2, and the value is ones, tens, hundreds, thousands, 7,532. Now we hide this 2. Our now ones, the digit which is at the place of ones is now 3. So is this number divisible by 2, or is this number an even number? No, not at all. In this given list, 3 is not available. So this number is an odd number, not an even number, and this is not divisible by 2. In the same way, if we hide 3 as well, we are having here 75, and at the place of ones we are having 5 here. So 5 is also not an even number. So 75 completely isn't an even number. This is an odd number, and this is also not divisible by 2. I hope you understood the concept. Now we go through some examples. 7, 6, 8. So this is also an even number, because 8 is even number, and this is completely divisible by 2. Now we have a number 490. At the place of ones we are having 0, so this is also an even number and completely divisible by 2. Now we are going to have another number 853 and 2. We are having 2 at the place of 1, so this is also divisible by 2 completely. Without dividing the number, we can easily tell that this is divisible by 2 completely, and this is also an even number. Why we can say that this is an even number and easily divisible by 2? Because we are having here digits from these digits. I hope you understood this concept. Now we have our second rule, and in this rule we are going to study about the divisibility by 3. Divisibility by 3. So the rule is very simple. If we sum all digits, if we sum all digits of a number, if we sum all digits of a number, means this is a number and these are their digits, these are its digits 2 and 4. This is the number and it has two digits 9 and 3. This is a number, it has three digits 7, 1, 1, 2, 3. This is also a number, this has three digits 1, 2, 3. This number is going to have four digits 1, 2, 3, 4. This also has four digits 1, 2, 3, 4. A single value of each number is known as a digit. Single value, this 3 is single known as a single known as a digit, this 9 as a single known as a digit, this one single known as a digit. So if we sum all digits, if sum means if we add all digits, if we add these all digits, if we add this all digits of a number, our number is here 42, And if we add these all digits, how many digits are here? Two digits here. 4 and 2 digits. 4 and 2. If we add 4 and 2, we will get 6. We will get 6. So and this sum is divisible by 3 if we divide these if we add these two digits and we have a sum, and that sum, if divisible by 3, then the number is also divisible by 3. We will go through with examples to make it clear and understand to you. If we sum all digits of a number and this sum is divisible by 3, then the number is also divisible by 3. Now we do it practically. uh, Here we have 42 at A. 42. Now this is our number. Now it has two digits and we need to sum these digits according to our definition. So 4 plus 2, 42. 4 plus 2 equal to 6. 4 plus 2 equal to 6. Now our question is that is this 6? Is this 6? After some we are having 6. If this 6 if this 6 is divisible by 3, then this all number is divisible by 3. If this number is not divisible by 3, then this is impossible to divide our original number completely to have 0. So now we say the table of 3. 3 ones are 3, 3 twos are 6. Yes, this 6 is divisible by 3. So in the same sense, this 42 is also divisible by 3 completely. Understood? Now we have number at 42, and according to the rule of divisibility by 3, we will add these digits. Here we are adding the digits of 42. 42. We have placed plus symbol between 4 and 2 to add both digits. 4 and 2, if we add, becomes 6 after addition. And now we check, is this 6 divisible by 3? Yes, this 6 is divisible by 3. 3 ones are 3, 3 twos are 6. Here, for your understanding, we going to divide this 6. Keep the 6 inside and keep 3 here. Why we are keeping here 3? Because our question is about 3. So 3 ones are 3, 3 twos are 6, 3 twos are 6. So we subtract here 6. From 6 to this 6 we have 0. So this is completely divisible by 3. This showing that this 6 is completely divided by 3 because our remainder is 0, not 1, 2, 3 or any other value. We are having 0 as our remainder, means this 6 is completely dividable by 3. Now this 0 tells that 6 is completely divided by 3. So from here we can say that this 42 is also divisible by 3. We are going to divide the 42 also. 42, keep inside 42 and divide it by 3. 3 ones are 3. Now from 4 subtract 3 we have 1, and this 1 is smaller than 3. We will also have this 2 here. Now 3 ones are 3, 3 twos are 6, 3 threes are 9, and 3 fours are 12. So subtract 2 from 2, 0, 1 from 1, 0. So this 42 is completely divisible by 3, because we have already seen through the rule that if we sum these digits, of a number which is 42. 4 plus 2 we are having 6, which is our sum. And now if this sum is divisible by 3, then complete 42 is divisible by 3. Understood? We will check other numbers if these numbers are divisible by 3 or not. At B we have 93. So this is our number, and according to the definition we are going to add these two digits of 93. 9 plus 3, we will have our plus here in between these digits. So after adding 9, we add here 9 and 3. 1 2 3 9 10 11 12. So this is 12. We keep here 12, and this is our sum. I am writing this sum to make you understand, okay? You will not write this word when you are attempting these questions by yourself. I'm just writing here to make you understand. Now this 12 is our sum. Now we want to check if this 12 divisible by 3 or not. Yes, this 12 is divisible by 3 because this 12 comes in the table of 3. 3 ones are 3, 3 twos are 6, 3 threes are 9, and 3 fours are 12. Uh, Here 12, 3, 3 fours are 12. 12 minus 12 we have 0, so this 12 is completely divisible by 3. This means this number is also completely divisible by 3, and we are not going to divide it. Without calculator we can easily say that this 93 is also divisible by 3. Okay, now just to make clarify to you, I am going to divide this number 93 by 3 to check whether or this scenario and formula was really helpful or not in doing so. Okay, so here I am going to have this. This is our real division. We need this division. Okay, but this is very simple. We without division, if you know about tables very well, if you know you have memorized tables very well, even we do not need to do this, but I did so to make you understand. We can easily say that 3 4 is 12, we are having 12, and this 12 is given in the table of 3, so this number is also divisible by 3 without doing this step. Now I'm going to do this also to make you understand and to check this rule, that this rule is true or not. Okay, keep here 93 and divide this 93 by 3. So first we will divide this 9 by 3 because this 9 is bigger than 3. So 3 ones are 3, 3 twos are 6, 3 threes are 9. So 9 minus 9 0. We will have this 3 under here. Now 3 ones are 3. Subtract 3 from 3. We have 0 after subtracting these 3 from 3. And here is 31. This is complete division when we have 0 as a remainder. So this 0 is remainder. This is 0 is remainder. Remainder means our rest value. Our rest value is 0, our last value is 0. So this number, this 93 is completely divisible by 3. We have also checked this in doing division. Now at number C we have understood, very easy. Now we have C, 711. This is our number. Now we sum the digits of 711. 711. Place add symbol between each symbol. Now add 7 8 9. So 3 threes are 9, So this 711 is divisible by 3. We have checked this. Now we will write here our answer, that 711, this is answer writing style. You will write your answer like this: 711 is divisible. When you will solve these questions, you will write answer like this: the 711 divisible by is divisible by 3. We have another example here, which is this D, 291. So we keep plus symbol between each given digits. Now we add these digits. So 9, 9, 10, 11, 12. We have 12 here. So this 12 is divisible by 3. It means that 291 is completely divisible by 3. So here we will write our answer, that 291 is divisible by 3. We have other example, which is E. At E we have a number to 2925. So now check the sum of the digits: 2, 9 plus 2 plus 5. So add these values: 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We are having here 18, and this 18 is divisible by 3. How? 18, 3 9 18. So this number is also divisible by 3. 18 is also divisible by 3. So now Alex, we have very simple rule at number 3, divisibility by 5. This is very simple rule, divisibility by 5. If a digit if a digit at one's place if a digit at one's place, remember we are discussing about the digit at one's place, not at thousands, ten thousands. We are discussing about the digit which is available at one's place is 0. If digit at one's place is 0 or 5, is 0 or 5, if we have this digit, or if we are going to have this digit at the place of ones, then the number is divisible by 5. Then the given number is completely divisible by 5. How? At A we have 50, and now we are having here at the place of ones we are having here 0. Now this is also given 0 here. So this number is easily divisible and completely divisible by 5. Means 50 comes, this number 50 is available in the table of 5. So this 0 is telling us, but where this 0, when this 0 is at the place of ones, ones 10, here we can look this ones tens, and we are discussing about the digit which is available at the place of ones. So this means that this 50 is completely divisible by 5, and without dividing this number we can easily say, just seeing this ones value, either this is 0 or 5. Now at B, we have a number which is 25, and at ones we are having 5. So this 5 is telling us that this is at the place of 1, and this 22 is completely divisible by 5. Understood? At C, we has number 905. This 5 is available at 1's place, so this complete number is divisible by 5. We have here 220. Because of 0 which is here at 1's place, we can easily say that this number is divisible by 5, because in 5 we have two digits 0 and 5, which tells us that if either of these digits, if 0 or 5 is available at the place of any given number, of at the place of ones, then the number is divisible by 5. Now here we have 2055 ones. Remember this rule. If you have studied this rule in your earlier classes: ones, tens, hundreds, thousands, ones, tens, hundreds, thousands, ones, tens, hundred, thousands. So here we are having 5 at the place of ones. This means this complete number is going to be divided by 5, and we are not using here calculator. Now we have number 350. Yes, this 350 is also divisible by 5, because we are having 0 at the place of ones. Now today's our last rule is divisibility by 10, which is very simple than this third rule. Divisibility by 10. If a number has a 0, if a number has a 0 at the place of ones, then this number is divisible by 10 completely. Now here we have 70, and at the place of ones we are having 0. Here we have 900, and at the place of ones we have 0. Here we have 0 at the place of tens. Here in 2050 we are having 0 at the place of tens. In 140 we are having 0 at the place of tens, and in ones, tens, hundreds, thousands, 2000 and 560, we are also having 0 here at the place of ones. This means that these all numbers are easily divisible by 10. 70 is divisible by 10 because of this 0. Because of this 0, this is also divisible by 10. Because of this 0, this is also going to be divided by 10. This is also going to be divided by 10 because of this 0 which is available at the place of ones. 140 is also divisible by 10 because of just this 0, and this number 2560 is also divisible by 10 because of just this 0 which is available at the place of ones. I hope you understood today's lecture, which is concerning about the divisibility rules, and we have studied in this lecture about the divisibility by 2, divisibility by 3, divisibility by 5, and last this one divisibility by 10, with a number of examples. Now you have to attempt an exercise which will be sent through a PDF document. Till then, take care of yourself and your family very much. Thank you for having me and attending this lesson. Bye.